All right, so here's one I'm hoping to do in class today, but if we don't have time in class, I'm gonna have the video made so you guys can watch it at home. It's number 9 on the practice. It deals with consecutive integers, or in this case, consecutive positive odd integers. So number 9 says, make sure you're looking at it, says find two consecutive positive odd integers such that the square of the smallest integer added to 3 times your notes say median, but it should say largest, or the larger integer, because there's only 2, there's no median integer. Median's the middle. There is no median, so it has to be the larger integer. So there's a typo there, apologize for that. So it's added to 3 times of the larger integer is 24. Okay, so his first idea is, what does it mean when it says 2 consecutive, come on now, 2 consecutive positive odd integers. Positive odd integers. Okay, so first thing, it's consecutive, so it's one right after the other. Positive obviously means it's not negative, and odd means it's going to be 1, 3, 5, 7, 9, so forth. Okay, and then of course integers is no fractions or decimals, so it's going to be 1, 3, 5, 7, 9. So maybe if the odd number is 15, the next consecutive is 17, so 15 and 17. Okay, so if the first one is going to be, let's just call it a value of x, x can be any odd number, any positive odd number you think of. 101, it's fine. Okay, whatever odd integer you want to come up with. What's the next one? How do I find the next one? Well, if I have, let's say, 5, the next odd integer is 7. So I'm actually going to add 2 to it. X plus 2, because they have a difference of 2. If you think about that common difference in a series. So 1, 3, 5, 7, 9, they're always a difference of 2. Even though it says odd, we're still going up by 2 to skip every even problem. Okay, so here's my 2 value. My x is my first term, x plus 2 is my second. So my first odd integer and then my second consecutive positive odd integer. Okay, so then it says such that the square of the smallest. Okay, so the square of the smaller, okay, so obviously x is going to be the smaller. So the square of the smaller, so you x squared, added to, that's pretty simple, plus 3 times the, once again, larger, so 3 times x plus 2 is 24, so is equal to 24. Now some of you like to use brute force and go ahead and just start plugging in numbers. You can try 1 and 3, then you can try 3 and 5, then you can try 5 and 7, then you can try 7 and 9, and see which one works. Here's an algebraic way to solve and get the answer. Once again, it's a quadratic. I have x squared plus 3x plus 6. Don't forget to distribute that 3 equals 24. All right, and then x squared plus 3x. If I subtract 24 from both sides, I get minus 18 equals 0. And hopefully we can see that that's going to factor and solve really easily. Okay, I write out my factors. I know that 6 times 3 is 18, so I'm going to have x plus 6 and x minus 3. 6 times negative 3 is negative 18. 6 plus a negative 3 is positive 3. Okay, so then once again, to solve it, we take each of these. We go x plus 6 equals 0, and x equals negative 6. Now, that is neither positive nor is it odd. Therefore, that's not my answer. So I come over here and I go x minus 3 equals 0. So add 3, x has to be equal to 3. That is both positive and odd. So there is my answer. X equals 3. So if x equals 3, the next one is 5, and there are my 2 consecutive positive odd integers. If you want to check it, the square of the first, which is 9, plus 3 times the larger, 15, is going to equal 24, and that certainly checks. Whoops. And that certainly checks. Okay? I hope to do that in class today. If not, there's the video of it.